Welcome to Study Loop.
Okay, so here we have a capacitor that has a capacitance C equals to 4.6 microfarad, right? That is initially uncharged and is connected in series with a resistor R equals to 7.5 kilo ohms, and the EMF source E equals to 245 volts. Okay, just after the circuit is completed, that means when time t equal to 0, when time t equals to 0, when time t equals to 0, so we have to find in part A what are the voltage drop across the capacitor. So at time t equal to 0, the charge q equals to, this is the expression for charge q while charging, q equals to q naught. Q naught is the maximum charge that can be stored in the capacitor minus RC. T is the time and RC is the the time constant of the capacitor. Now, at time t equal to 0 implies q equal to 0 because e to the power 0 is 1, 1 minus 1 makes q not 0. So q equal to 0, so q is equal to, which is equal to q's product of c and v. Now c can be 0, this implies v equal to 0. Right, so let me write this as Vc. So the voltage across the capacitor just immediately after the connection of the circuit will be 0. Okay, so we are done with part A of the question. Part B of the question says to find the voltage drop across the resistor. Now the EMF E is the sum of voltage across the capacitor and the voltage across the resistor. Right now, since Vc equal to 0, so this makes me Vr should be equal to the EMF E, and this is equal to 245 volts. So we also found out uh, the voltage, the potential difference across the resistance at initial time, that is t equal to 0. Okay. Now what is the charge on the capacitor? Well, we have already figured that out here. Look here. For C, Q equals to 0, right? Okay, now part B of the question asks us to calculate the current through the resistor. Now current through the resistor is equal to the voltage across the resistor upon the resistance. Now the voltage across the resistor is full E, that is 245 upon, now what is R, 7.5 kilo ohm. So, and this is in volts. So this gives me I equals to 32.67 milliamperes. Okay, so this is the current to the resistor. So part E says after a long time, so long time means t tends to infinity, right? Uh, after the circuit is completed, okay, a long time after the circuit is completed, what are the values? Okay, we need to find out all the values from A to D. So let's do it. So again, let's start from Q equals to Q naught times 1 minus e to the power, since t goes to infinity, so e to the power minus infinity is 0. So 1 minus 0 is 1. So Q is equal to Q naught, right? Now Q naught, uh, we need to find Vc. So Vc is equal to Q naught upon C, right? Because Vc is equal to Q upon C. Now Q equal to Q naught, so Q naught upon C. Now this should be equal to E. Q naught by C is E. So the EMF is 245. So this is the voltage across the capacitance. So let me mark this as green. Okay, this is after a long time t, infinity. So we need to find next is Vr. Now Vr equals to again E minus Vc. Now E is 245, so 245 minus 245. This makes it VR equals to 0, isn't it? So this makes it VR equals to 0. So we are done with part B. Now let's continue to part C. And now in C, we need to find Q, right? So Q is equal to Q naught, which is equal to E times C. Now E is 245 and C is given, right? C is 4.6 microfarads. 4.6 into 10 to the power minus 6. Therefore, Q equals to 1.127 microcoulomb. All right. Okay, so we are done with this as well. So the next part is, sorry, this is millicoulomb. I just missed here. Millicoulomb. Okay. So the next part is to calculate uh, in the D part current I, right? So current I now equals to VR upon R. Now since VR equal to 0, so this also should be equal to 0. Well, I should have boxed it in green because this is after a long time t. Okay, so this ends the solution to this question. Thank you for watching.